Hello and a very warm welcome on behalf of NTI Audio. Thank you for joining us for today's webinar. The topic of this webinar is the measurement of sound insulation. My name is Markus Becker. I'm moderating this presentation and I'm assisted today by Bernard Nix, our sales director. He will take care of the incoming questions and he will assist me whenever necessary. Here you see a list of the topics that we have prepared for you. We will say some words about the required equipment, about airborne and impact noise measurements. We will clarify some terms and parameters and the issue of the microphone positioning. We have a brief statement about the reverberation time measurement, which is also part of this whole procedure. And then we have prepared a practical presentation for you. At the very end, we will summarize the key issues and provide some hints and tips before I will take a look on the questions that have come in and provide some additional comments. I expect that the webinar will last in the range of about half an hour. Let us first take a look on the two different ways we are measuring sound insulation. The first one would be the airborne noise insulation. Here we have a schematic sketch of a person who is apparently annoyed by incoming sound. So the causes can be outside of the building in which he is located or within. In both these cases, the sound would be transmitted via the air. That's why we call it airborne noise. And this would either happen through the facade or in-house, which is the more common or the more popular, the more frequently applied measurement. The second case is the impact noise. We see that here schematically by this dancing couple who are stamping on the floor. So this stamping will result in a noise that is audible here in the room below, and this impact noise is of course also something that needs to be measured and quantified. In this presentation we will focus on the in-house airborne noise and on the impact noise. The facade measurement is a special case which is very closely related to the in-house measurement, so we will not say too much about that in this presentation. What do we need as equipment for these measurements? First of all, we need an omnidirectional loudspeaker with amplifier. We need a tapping machine for the impact noise measurements. We need, of course, a sound level meter or even several ones. We will come back to that issue later. And we need a software that allows us to calculate the results from the various measurement data that we are acquiring. Now let us take a closer look on the airborne noise measurement. We have a sending room and we have a receiving room. To start the procedure, we would measure the background noise in the receiving room. It is quite apparent that this value plays a major role because when we measure the incoming sound from the neighbor room in a later stage, we have to differentiate that from the existing background noise. And for that purpose, we have to measure this value first. Second, we place the omnidirectional sound source in the sending room and we adjust its sound pressure level so that the sound transmitted through the wall, ideally, is minimum 10 dB higher than the background noise in this receiving room. If you cannot reach this 10 dB difference, it's not a big problem. The software that we are presenting in the later stage of this webinar can cope with that situation, but if possible, adjust the volume so that we have this 10 dB difference between the transmitted sound and the background sound level. Next, we will measure the noise level here in the sending room, which is called L1, and then the noise level in the receiving room, which is called L2. Then, in a third step, we will analyze the reverberation time in the receiving room. and finally calculate the results from these various measurements that have been acquired in the two rooms. Now I have mentioned a couple of values and parameters. Let us take a closer look on them. I will not go into all the details, but I have listed here a couple of very frequently used measurements and calculation results. Starting with the two levels I just mentioned before, L1, L2. These are average sound levels. And what is very important, these are not broadband levels. We are always analyzing and measuring the spectrum. We want to know the spectrum of the corresponding sound levels. By having these two levels, we can calculate the noise reduction, or more important, the normalized noise reduction according to this formula. And here see we have this parameter T. T is the reverberation time of the receiving room. It is quite apparent that when you have a room which is exposed to neighboring sound, the reverberation time in the receiving room has an impact on the overall sound level that is happening. So that is the reason why we have to acquire the reverberation time in the receiving room. Here we have the apparent transmission loss, which is another value that can be calculated. And here see the area of the common partition or the volume of the receiving room play a major role. By the way, these standards that I have listed here are all referring to the ASTM, the American standard for these noise insulation measurements. Down here we have a third important formula which refers to the impact sound level measurement. Well, these three formulas are very frequently required for sound insulation measurements. Some additional hints for the airborne insulation test. First of all, how long do you have to measure? That depends on the frequency range in which you are interested. If you say, okay, my measurement range starts at 100 Hertz upwards, then you can renounce, or you can restrict yourself to 6 seconds measurement duration. Whereas if you want to cover the whole frequency bandwidth from 20 Hertz upwards, then you need a 15-second measurement duration. Next, you can execute these measurements sequentially or in parallel. Sequentially would mean you first measure the sending room and then the receiving room, as stated before. And in parallel would be if you have, for instance, two sound level meters available, you can connect them to the laptop as an example and measure the result in one step. So you're measuring both rooms in parallel. Keep in mind, it's not just one measurement that you execute per room. You have to do several ones, and you have to move the microphone, the test instrument, the position of it in the room to acquire different results or several results per room. That applies not only on the measurement but also on the position of the sound source. So you have to repeat the measurement with different positions of the sound source. And last but not least, keep in mind, airborne noise measurement is a relative measurement. If we have a higher level here in the sending room, we of course get a higher level in the receiving room, but most important is the difference between these two values. That is the core information we are getting from this measurement. I've been talking about changing microphone positions. So there are two ways to achieving that. One is here the microphone boom. This is an automated motor-driven device that slowly rotates the microphone in a circular plane. Or you can do that manually by holding the microphone or the sound level meter. There are different patterns you can follow depending on the available space in the room you are. For instance, the semicircles are recommended for very narrow conditions. These sketches here have been derived from the ISO 16283 standard, by the way. So this is, of course, the easier way to do it. It takes more effort to set up a test by doing it manually. Now let's swap over to the impact noise measurement. Here we start the same way. We first measure the background noise in the receiving room, and then we set up the tapping machine. Now, this is a very important issue. When you set up the tapping machine, you have to do that carefully. This is a precision device that needs precise and accurate installation. And we have recorded an instruction video on this procedure. You don't need to write down this link here. Just visit our website, search for the tapping machine, and there you will find a video that shows you how to do that properly in order to make sure that the tapping machine is operating correctly. Then you run the machine, you switch it on, and you measure the sound it creates in the room below. So you measure the sound level L2 in the receiving room. And at the end, you calculate the results. Of course, you also have to consider the reverberation time as stated before. Now, what is important in contrast to the airborne noise measurement, here we have an absolute measurement. The tapping machine will always produce the impacts of these falling hammers in a defined way, so there is no higher or lower level that has been created. It's always standardized, and all you have to do is to measure the receiving room. That is why it is an absolute measurement. Now the reverberation time, just one hint, we have just launched a new website on the topic of RT60. It's a very nice website where you find lots of information, background information, practical information, how to do the measurement. Yeah, you can visit our website. You will find it easily. And in addition, just to mention that we had already a webinar on RT60 measurements some time ago. You will also find the recording of this RT60 webinar on our website. Normally, you execute the RT60 measurement in building acoustics again with the omnidirectional sound source because you have it anyway on site. You need it anyway. And the test signal, you certainly know, is gated pink noise. Well, I'm already at the point of my practical presentation. For that purpose, I have here in my room such a dodecahedron speaker. I have actually two XL2 connected to my PC. One XL2 is in my room and where I'm sitting, the other one is next to it. So I can simulate such a sound insulation measurement, and I have the sound insulation reporter software installed on the PC, and that is what I'm going to run right now. So here you see the startup screen of this software. And when you start with a new analysis, the first thing you do, you open a new file and you select the applicable standard. So here, talking about the United States, for instance, we would select the ASTM. You see there's a couple of other standards implemented in the software. You just select the one that you need in your country. Then you decide whether you want to execute airborne, impact, or facade measurement. I'm going for airborne. Now, in contrast to what I said before, I will restrict myself just to one position of the speaker, and here you can select the results that the software shall calculate for you. Just a side note, if you're more acquainted with feet, you can also change the unit for the dimensions of the room that need to be entered. I confirm, and you see down here in the status bar already, this is now the applicable standard for this calculation, for this analysis that I'm going to do now. Now you have now two options to import the data, the measurement data into the software. The first one would be, you click here on import and you select the data from the XL2. You have, let's assume you have recorded the all the data on the Excel2 and saved it on them. I have done that before. I have transferred this data to my computer. So here I select these measurement results. And you can see they are dropped here and displayed in graphical way. Now, the issue is now the software needs to know what was the sending room, what was the receiving room, what is background noise. So you have to manually assign this information to these corresponding curves. Well, I know my first 3 measurements were executed in this sending room. That's why I manually assign here to L1. And the second 3, by right-clicking, I assign that to the receiving room, L2. The reverberation time is easily detectable by the software. That's why it already has assigned it. And the last measurement down here would be the background noise. Now, having made these assignments, I can swap over to the calculations page. And here I can click on the individual results, the averages, and all the additional data. I could even disable individual curves if they do not fit, if there something went wrong during the measurement. So here I can get a very nice overview on the acquired data. Then final step would be, of course, to customize my report or my measurement. I would, for instance, enter the name of the client. I would enter the name of the location and so on and so forth. I would need to, of course, also adjust the volume and the dimensions. I'm just leaving the default values now, but you see this is the customization that you have to do. And in the end, you click here on the result view, and this is the standardized display. You can print that out, and it completely conforms to the standard that shows you the corresponding results, the noise reduction, the normalized noise reduction, or here the apparent transmission loss. And just one more hint, down here you see the ASTC. This is according to the new standard. The apparent sound transmission class is also displayed here on this result screen, which you, as stated before, can also print out. Well, there is a second way of executing a measurement, and I want to show you that a little bit in practice. And for that purpose, I have prepared here our webcam in my room. I hope you can see that. You see here, this is one of the 2 Excel2 devices. Here I have the amplifier for the omnidirectional sound source. Now, I will now create a new file. Same settings, ASTM standard, airborne noise 1 position, okay. But now I will execute, I will let the software guide me through this measurement. And for that purpose, I connect my PC to the 2 analyzers, the 2 Excel2 analyzers. You see here, I have already assigned them to the source room and to the receiving room. I have selected the measurement duration, 15 seconds. And I could also connect the software to the power amplifier in order to control the sound that is generated from the omnidirectional loudspeaker. I'm renouncing on that here in my presentation. I'm going to rather control the amplifier via remote control. You're going to see that. I confirm. Now, before I start the measurement, I have to put on some hearing protection. It will be quite loud here in this room. Just to let you know, as soon as I click here on the start button, you will see down here a countdown timer which shows me the 15 seconds duration that need to be expired before the final result has been acquired. So I will put down my headset for a moment and start the measurement. I will actually execute 2 cycles of these measurements. Maybe you have seen, hopefully, the countdown timer down here. You have seen how these data have been acquired, and that is very comfortable with this solution. The software directly assigns the acquired results from the two XL2 devices to this list of measurements. Quite obvious, the PC knows which analyzer is doing which measurement, so it can directly assign the corresponding data. The next step will be to measure the background noise. So now, of course, I need a silent room, and I start again. And third step would be the RT60, the reverberation time. For this purpose, I'm going to put down my headset again and switch on and off the loudspeaker in order to allow the instrument to trigger to the switch off of the turning off the loudspeaker and measuring the reverberation time. Maybe you have noticed here on the screen of the XL2 the decay of the sound that was created, and here you see the corresponding result. So now I have all the data I was looking for. I can double check here on the screen. It's same as before, and go to the result screen where I have the standard conform printout of my measurement result. Good. Let me get back to the webinar presentation. And provide some additional hints. First of all, when you want to analyze, when you want to measure these different steps by using the XL2 manually, holding it in your hand and executing these measurements, we recommend that you use the so-called sound insulation profile. This is a file that we are providing free of charge on our website. So you can download it from there, you can install it on the XL2, and it will simplify the operation of the XL2 on site because it just supports the sound level measurement and the RT60 measurement in the way that is needed for the sound insulation analysis. Second, when you think about buying an omnidirectional loudspeaker, dodecahedron loudspeaker, please keep in mind that sound insulation measurements usually take quite a long time. As stated before, you have to change the position. You have pretty long measurement periods at several locations. So it's quite usual that you are running this loudspeaker for a long period of time, maybe even 1 hour at a very high level. And therefore, it is very important that this created sound level is stable. Of course, the loudspeaker will heat up over time, and normally it then loses efficiency. But good dodecahedron loudspeakers have a low power compression, which means the generated sound pressure level is quite high, despite you're using it at high volume for a long period of time. Power compression, the weight of the loudspeaker, and the maximum level it can create are the most important parameters when you want to buy such a device. Well, what are the targets you're looking for? First of all, airborne sound airborne sound is the better, the higher it is. So a high airborne sound insulation result indicates that you have a good insulation between the two rooms. With impact noise, it's just the opposite. Here, a low result is what you're looking for, because a low impact noise result means a good insulation between the upper and the lower room. Last but not least, if you have results that are not satisfactory, if you have to improve the situation, what can you do? Talking about airborne noise, you can improve the wall structure. You should watch out for leakages. Leakages are always bad. They create or they diminish, they reduce the sound insulation, so you should fill them up. Or sound absorbers would be another option to improve the situation regarding airborne noise. When we talk about impact noise, of course, the building structure plays a key role. Maybe a floating floor would be a solution, or the installation of carpets could help to improve the situation if it's not acceptable. Here are some actual limits from England and Ireland, the corresponding national building regulations. You can see here for airborne noise there is a minimum result that needs to be achieved in England by 45 dB. In Ireland it's even 53 dB for new built dwelling houses or flats, whereas, as stated before, impact noise should be low. For that reason, here we have a maximum value that must not be exceeded for England and for Ireland, with the corresponding results, definition of the results. Good, I'm at the end of my presentation. I want to thank you for your attention, and I would be happy to welcome you again in one of our future webinars. You will be informed via email as usual.